Hi, Bella, can you hear me?
Yes, we are here, Yuri.
So everything's okay,
Yes,
right?
doctor. Yes,
Video can
doctor.
see, audio can listen, so everything okay,
Okay.
Yeah,
Okay.
should be okay, Dr. Lee.
Okay, thank you.
Kat mana? Tak boleh. Saya nak ambil. Tapi still macam ada tu macam tu. Hello?
Hi, good morning, everyone. Just want to make sure that all our speakers is here so that we can start, on timer. So we have first Dr. Nazia is here. Mrs. Hazira. Mrs. Hazira, is it Miss Ira?
Miss Hazira, can you enter live again? Sorry.
So Shabila is here.
Okay.
Dr. Nora Z. Lawati is here, and yeah, Miss Ira, you are Mrs. Hazira, is it?
Yes.
Okay, that's good. So I think we have one more invited speaker, Professor Asad Ali, still not joining yet. I think it's okay because he's the last presenter for this section. Yeah, and I want to confirm again. Our evaluator is here, so Dr. Ong is not here. Suhaimi or Shabila, can you inform Dr. Ong to join the sections now? Okay, because now is
Okay,
10.
okay, doctor. I will contact him.
Okay, yeah. Okay, so let me have some briefing first. Okay, so good morning again to everyone here, ladies and gentlemen. Welcome back to this conference, MICNC 2021. And we are now in this sections, energy, soil and gas, synthetic chemistry techniques. So I am Lee, the senior lecturer from Nanotech University Malaya, and I will chair the sections for today's together with the sections moderator, Madam Suzaini and Miss Sabella. So I think all our speakers already request to share the audios and video. So yeah, I can see some of you on screen, and yeah, the speakers is muted now. Okay, so for your information, for the oral presentations, it will have evaluated by 2 awards. Okay, the first is the best sections presenter, which will be announced at the end of the sections. And the second is the Best Presenters Award. This one will be announced during the closing ceremonies, and it will offer the prize, okay, 500 to 1,000 ringgit Malaysia with the trophy and the award certificate. Okay, so for those who have any questions to the presenters, as well as if let's say any technical problems from presenter, you may inform through this Q&A box or chat box. So our IT personnel will reach to you. Okay. One more information is the presenters given 15 minutes for the presentations and 5 minutes for the Q&A sections, whereas the invited speaker are given 25 minutes for the presentations and 5 minutes for the Q&A sections. We will remind the presenters to the end of the presentations 2 minutes before the sections end. Okay, so before we start these sessions, I would like to invite all to turn on the camera so that we have these photo sections, and our IT personnel will take a screenshot and then we'll share to the WhatsApp group later. Okay, shall we? Please turn on the camera, yeah, so that we can have a screenshot. Bella or Suzanne, can you stop sharing the screen first? Yes. Yeah. Hi, everyone. Okay. So 1, 2, 3. Smile. Is it okay? Maybe we can have one more time. One more time. 1, 2, 3. Okay. Okay, done. Okay, thank you, everyone. Okay, so yes, we will start our first presentations by Dr. Najia binti Nadil with the title of Surfactant Evaluations for Enhanced Oil Recovery, Phase Behaviors and Interfacial Tensions. So please welcome Dr. Najia.
Okay, thank you. Let me share my screen first. Okay. Can you see my slide in presentation mode?
Yes, it is clear.
Okay. So introducing myself, I'm Najia binti Nadir. So a researcher from Petronas Research Sdn Berhad under Specialty Chemicals Technology Department. So today I'm going to present one of our study entitled Surfactant Evaluation for Enhanced Oil Recovery, Phase Behavior and Interfacial Tension. So these are my presentation outline. So I'm going to start with the introduction of our study, followed by the objective and types of surfactant that we use in our study, methods, result and discussion, and finally with conclusion. Okay, as introduction, there are 3 stages of oil recovery, which are primary, secondary, and tertiary oil recovery. During primary oil recovery, the crude oil is driven into the production well by the difference in the natural pressure between the surface and the reservoir. Meanwhile, for secondary oil recovery, the crude oil is extracted from the underground reservoir by maintaining the reservoir pressure through 2 techniques, which are water injection and water flooding. So the oil recovered during this phase is around 20 to 40%. And during the last stage, which is the tertiary oil recovery, or also known as enhanced oil recovery, EOR, the remaining oil is retrieved using additives such as chemicals, heat, or microbes. So during this last stage, the oil recovered is up to 60%. So in our study, we are going the chemicals type of additive, which is to be specific surfactant. So surfactant is composed of two functional groups, which are non-polar hydrophobic or soluble tail and polar hydrophilic water soluble head. There are 4 classes of surfactants which are classified by the charge of their hydrophilic head. So from the figure you can see the cationic has a positively charged head, anionic has negatively charged head, non-ionic has no charge, and the last category of surfactant is amphoteric, which has both positive and negatively charged head. So the selection of the right UR is an important but demanding task due to a series of screening procedures that need to be executed in order to have a comprehensive evaluation. Surfactant may perform differently depending on the reservoir condition such as temperature, pressure, salinity, and type of crude oil. 2 criteria of a good surfactant for UR are: first, good thermal stability at reservoir temperature, and second, has capability to reduce the interfacial tension to less than or equals to 10 to the power of minus 3 millinewtons per meter. This is because as when the surfactant reduces the interfacial tension between the crude oil and aqueous phase, the capillary number will increase, thereby decreasing the capillary pressure and allowing aqueous phase to push out and mobilize the trapped oil, and thus enhancing the oil recovery. So the objective of our study is to perform the initial screening work for surfactant selection, which can be divided into 3 phases. The first one is solubility and compatibility test. Second is phase behavior evaluation. And third is the interfacial tension measurement. So by doing this screening work, we will be able to identify a potential candidate of UR surfactant for further fluid rock evaluation. So there are, in our study, there are 10 types of surfactant which can be classified into 3 classes. So surfactant 1 to 3 is non-ionic surfactant. Surfactant 4 to 6 are anionic type of surfactant. And surfactant 7 to 10 is are amphoteric type of surfactant. So for the methods, we started our study with the computability and stability test. This test is done to check the surfactant solubility and compatibility with synthetic brine at ambient and reservoir temperature. So from this figure, we will report the result as soluble if the solution is clear, and non-soluble if the solution is cloudy or there is phase separation or precipitation. After that, we proceed with phase behavior evaluation. So during this stage, we will select the surfactant with surfactant brine oil system, which has Windsor type 3 or Windsor type 1 microemulsion at reservoir temperature. So from this figure, the Windsor type 1 has the microemulsion in the water phase. Meanwhile, Windsor type 3 has the microemulsion in the middle phase, and Windsor type 2 has microemulsion in the oil phase. So only Windsor type 1 and type 3 is considered as suitable for the UR work. So after we determine the phase behavior, we will proceed with the interfacial tension measurement. So during this stage, we measure the IFT of surfactant brine oil system at reservoir temperature using M6500 spinning rod tensiometer. Or this tensiometer also can be known as Grace instrument. So the philosophy of this instrument is the diameter of the oil droplet, which is elongated by the centrifugal force due to the rotation speed, correlates with the interfacial tension. So from the solubility and compatibility test, so this test is performed because the surfactant solubility decreases as the salinity increases. Hence, surfactant solution has a high possibility to form precipitation in brine due to the coexistence of divalent or multivalent ions. The solutions must be in soluble composition at both ambient and reservoir temperatures in order to ensure a single phase solution before and after the injection. This is because the injection of non-soluble composition can result in non-uniform distribution of the injected solution and non-uniform transport due to phase trapping or different motions of the coexisting phases. So from this figure, you can see that all surfactants pass the solubility and compatibility test since all solutions are clear, and all surfactants were further evaluated for phase behavior. So during this stage, the phase behavior evaluation is an helpful approach in screening the various types of surfactant system. This is because the phase behavior must be determined through an experimental study, since there is no common equation of state exists even for simple microemulsion. Therefore, this is because the complexity and dependency of phase behavior depends on the various parameters such as type or concentration of surfactant, co-solvent, types of hydrocarbons, brine salinity, temperature, and pressure. So from this figure, you can see that all surfactants display either Winsor type 3 or type 1. So for example, you can observe that surfactant 4, 5, 8, and 10 has Winsor type 3 since the microemulsion is in the middle phase. Meanwhile, others surfactant has Winsor type 3 and type 1 since the microemulsion is in the oil phase. If the microemulsion has a type 2, so you can observe the microemulsion in the oil phase. So from this result, all surfactants will proceed with the Ift measurement. Okay, so for the Ift, the general principle for a successful surfactant flooding in AOR is the Ift should be reduced to ultra low at the range of 10 to power of minus 3 millinewtons per meter and below of a typical reservoir bright crude oil system to overcome the capillary forces holding the oil in a reservoir. So after we use the GRACE instrument and then we observe the diameter of the oil droplet, we use this equation, which is the Van der Waals equation, to determine the interfacial tension. So the gamma is the Ift, and the delta rho is the density difference between the surfactant in brine and the crude oil, and D is the diameter of the crude oil, and then theta is the rotational speed of the tensiometer. So after doing the Ift test, we observe that the lowest Ift values for all surfactants were observed at 0.1% of surfactant concentration with Ift of less than 30 times 10 power of minus 2 millinewtons per meter, except for surfactant 9 and 10 with Ift around 45 to 55 times 10 power of minus 2 millinewtons per meter. Besides, all surfactants have significantly lower Ift as the surfactant concentration decreases from 1 to 0.1%, except for surfactant 4, 5, and 8, which have the Ift at a range of 10 to 30 times 10 power of minus 2 millinewtons per meter. And lastly, that we can observe from this graph is surfactant 6, which is an ionic surfactant, or the name is sodium decyl glucoside hydroxypropyl phosphate, gave the lowest Ift value of 8 times 10 power of minus 3 millimeters per meter at 0.1% of surfactant concentration. So after that, when surfactant concentration of surfactant 6 was further decreased to 0.05%, so we determined that the Ift value increased instead of decreasing. Hence, from that, we can conclude that the optimum concentration for our surfactant is at 0.1% with the Ift value of 8 times 10 to power of minus 3 millimeters per meter. The surfactant cost greatly contributes to the overall cost of the chemical EOR project. Therefore, since surfactant 6 decreases the Ift value to an acceptable range of Ift at a very low surfactant concentration of 0.1%, surfactant 6 can be considered as a potential candidate to be further evaluated with thermal stability, surfactant absorption, and core flooding. So comparing the phase behavior and IFT result. So even though because during the phase behavior, we initially state that when we got the type 3 microemulsion, then the IFT value will be like ultra low, which is around less than 10 times to the power of minus 3 millimeter per meter. However, when we measured the IFT, we observe that the surfactant which has the type 3 microemulsion doesn't have the lowest IFT result. This is because the phase behavior and IFT can be compared directly, since the oil to water ratio in phase behavior evaluation is around 10 times higher than the IFT measurement. Because during the phase behavior, the oil water ratio is 1 to 1. Meanwhile, for the IFT, we just insert a small amount of the oil droplet inside the surfactant. Okay, so as the conclusion, all tested surfactants successfully passed both surfactant compatibility and phase behavior tests, since all of them showed soluble composition and have either Winsor type 1 or type 3 microemulsion respectively. For the final evaluation on IFT, only one anionic surfactant, which is sodium desaglucoside hydroxypropyl phosphate, gave the lowest IFT value of 8 times 10 power of minus 3 millimeters per meter at 0.18% of surfactant concentration. As the suitability of this surfactant for AOR work can be further tested during the fluid rock evaluation. Okay, thank you. That's all from me.
Okay, thank you very much, Dr. Nazir. Any questions from the floor? Okay, I have one question, Dr. Nazia, which is this is a very interesting topic. So, may I know what is the meanings of the fruit rock evaluations that you mentioned for your study? Fruit rock evaluations, is it right?
Because as you know that for the underground like reservoir, there is the oil is trapped between the fluid, right? So that's why when we because currently we are doing our study only using the fluid, which is the surfactant and the crude oil itself. But then we have to consider also the factor of the rock, because since we need to like deploy our surfactant inside the reservoir, because and then to take out all the remaining oil that trapped between the rock. So that's why for to simulate the real environment, so we need to do the fluid rock evaluation.
I see. So this is the coming study that you wish to perform, right?
Yeah.
For your optimized emulsifier. That's a factor, right?
Yes.
Okay. Yeah. So okay, thank you very much, Dr. Nazia. So in
Okay.
case the floor have more questions, you can put in the chat box. Okay. So next come to our next presenter, which is Mrs. Hazira Bintinga, with the title
Yeah.
of Carbohydrate-Based Amphoteric Surfactants for Improved Wellness and Consumer Benefits for Body Wash Formulations. Okay, please welcome.
Yeah, thank you. Let me share my screen. Okay, can you see my screen?
Not yet.
Yeah, wait.
Miss
Now?
Ira, maybe you can share your full window, because we know that some of the presenter having the same issue as you. So maybe
Uh,
try share the full windows so that you can do the presentations.
okay. Okay. Do I need to on camera?
It's okay. It's up to you.
Okay, thanks.
Once
Okay.
the slide is ready.
Okay, right. Okay, now you can see my slide, right?
I think it's still loading.
Oh, okay.
Do you turn on your slide?
Yes,
PowerPoint?
still not yet.
How about others? Can you
Um,
see the slide? Suzaimi, Mila?
If you have problem to show your slides, maybe you can share your slides to us.
sure, where?
Can you send to my email and send you the address in your WhatsApp?
Boleh, boleh. Wait.
This is to maybe you can share the WhatsApp group to Suzaimi or Shabela. Right.
Okay, I can see my two.
We can see your full screen.
All right.
Just that I'm not sure why the slide is not there.
Yeah.
Is it you can maybe you can close your PowerPoint again and turn on again because we can't see.
Okay, I can try. Wait a minute.
Yeah, sure. You turn on your slide?
Yeah, but waiting loading.
I see, okay. So if let's say this trial still cannot make it, I suggest that Miss Ira, you can emails or WhatsApp to the IT personnel, Suzaimi or Shabila.
Okay.
Okay. While we are waiting for your presentation slide ready, maybe we can go to our next presenter.
Sure. Wait.
Okay.
All right.
Okay. So yeah, maybe you can have a try, or you want to just send to the IT personnel. Yeah, maybe you can stop
Okay.
sharing.
Now you can see my slide. Still not.
I think my side still cannot see the slide. Are you there?
I've already sent you my email in the chat box. Miss Hazira, you can send it directly to me. I can open your slides immediately.
Okay. Madam Suzani, maybe you can liaise with Miss Ira for this case. So yeah, we come to our next presenter, which is Shabila, with the titles of Synthesis and Antioxidant Study of New Semicarbides and ThiosemiCarbide Derivative with applications on synthetic lubricant oil. Okay, Shabila, are you ready? Is it okay? So I will pass the floor to you. Okay, good luck. Any problem, Shabila? Yeah, we cannot hear you. Maybe can you turn on your, can you unmute? You cannot make it. Oh, our side cannot unmute. Yeah, I try. Yeah, is it okay? Yeah, I think this is the challenge to having some virtual presentations here. After all, do you have
Actually,
any?
I learned one trick about this hopping sessions.
Mhm.
Whatever happens, right, you can try to press the refresh button and then start it all over again. Shabila, you nak cuba tak? Your own Internet Explorer refresh.
So this is from Miss Ira, is it? Hazira. Oh, yeah, you can, you're able to share the slide, Miss Ira. So what about we go back to you first? Bella also okay already.
Okay.
Okay, so who's want to having the presentation first? Is it Miss Ira here? Or your Bella want to try first?
I don't mind because I will share my video.
I see. Miss Ira, are you there? I think he's not there. So we just start with Shabila first, okay? Yeah. So please welcome Bella.
Okay, thank you. Wait. Assalamualaikum and good day.
You need to share your screen. Okay, we can see it.
Assalamualaikum and good day everyone. I'm Shabla Sazil, research student from University Malaya. Today I would like to present my research on synthesis and antioxidant study of new semicarboxide and thiosemicarboxide derivatives with application on synthetic lubricant oil. This is the outline of my presentation. Before I start to share my experimental details, I would like to explain the basic knowledge for us to understand my research study as my introduction. I'm aware that the audience from this session might be from different research backgrounds. Basically, my research is about synthesizing new antioxidant for synthetic lubricant oil. We can see people are aging. We can observe rusting happens on metals. We notice that apple can become brown. Why? Because the oxidation reaction. How this oxidation happens? Because of the presence of free radical. Okay, now what is free radical? Free radical are atoms or molecules that is unstable due to containing one or more unpaired electrons. Means they have absence of electron. Unstable molecule, free radical, used to attack healthy molecule due to its absence of electron. The radicals could be found in different forms, such as hydroxyls. That's why the presence of water could cause rusting. Endogenous free radicals are produced from mitochondria, immune cell activation, inflammation, aging, mental stress, exercise, and infection. Whereas exogenous are resulted from environmental factors, for instance, air and water pollution, alcohol, tobacco, smoke, heavy metals, transition metals, industrial solvents, pesticides, certain drugs like paracetamol, and radiation that could penetrate into the body by different routes. Oxidative imbalance in the human body leads to many chronic diseases. Synthetic antioxidants do not occur in nature. They are radical scavengers that chemically synthesize and added to food or industry goods in order to protect them from oxidation damage. BHT is the most common primary synthetic antioxidant used in different applications such as food packaging products, cosmetic, pharmaceutical, petroleum products, and rubber. Butylated hydroxyl toluene is one of the most commonly used phenolic antioxidant in petroleum products. Okay. The addition of different chemical additives to the base fluids improves and sustains lubricant properties. Additives are added to optimize properties such as anti-friction and anti-wear, anti-corrosion, viscosity booster, detergents and dispersants, antioxidant stability, and PowerPoint depressant. Just to show that these are some examples of antioxidant additive for lubricant. The engine oil's oxidative breakdown creates sludge and deposits, deteriorates the oil's viscosity characteristic, and produces acidic bodies that cause engine parts corrosion. The most critical aspect of lubricating oil is to maximize oxidative stability. Exposure of hydrocarbons to oxygen and heat will accelerate the oxidation process. So this is the main problems. The environment in the engine promotes the oxidation that creates sludge. Over the past decades, there has been a dramatic increase in the development of environmentally friendly lubricant formulation from renewable resources to reduce dependency on other Earth fossil-based resources due to the rising ecological concerns and growing preventive protocols. Synthetic polyol ester-based lubricant derived from naturally occurred oil or fats is bio-based lubricants, which has excellent lubricity, high viscosity index, and biodegradable have gained great consideration. However, it is failed to get wide approval as lubricant due to its poor oxidative and thermal stability. The reason is the presence of unsaturated bond in the oleic acid part of the molecule is sensitive to chemical oxidation reactions in the presence of oxygen, water, and metals under elevated temperature without the addition of antioxidants. Trimethylpropyltriolate, a petrochemical derivative with naturally derived oleic acid, is the most widely used ester-based lubricant. It has outstanding lubricity, low temperature properties, high viscosity index, and improved oxidative resistance than vegetable oil. Thus, it has promoted to be a competitive green lubricant. Although TMPTO offers superior lubricant properties than mineral oil, its wide application is limited due to its poor oxidative stability towards oil from premature oxidative degradation. Therefore, the development of oxidations with better oxidative stability properties and less toxicity appears to be crucial for the generation of new antioxidants. We assembled several antioxidant functions in one structure by incorporating BHT moiety into semicarbaxide and thiosemicarbaxide compounds to obtain better oxidative autosynergistic effect. This research deals with the preparation and evaluation of new series of semicarbaxide and its corresponding thiosemicarbaxide derivatives bearing BHT moiety for their antioxidant activities using DPPH assays and DSC. This research would help researchers to have deep understanding on potential between multifunctional semicarbazide and thiosemicarbazide derivatives as antioxidant inhibitor for future lubricant oxidative stability industry perspective. So this is my objectives, research objectives. The first one is to synthesize novel semicarbazides and thiosemicarbazide bearing BHT antioxidant moiety for lubricating oil. And the second one is to verify the antioxidant activity of the synthesized semicarbazides and thiosemicarbazide derivatives using DPPH assays and DSC. So the method for my research is the first step is to synthesize and characterization of the new compound. All the synthesized compounds are confirmed by proton NMR, carbon NMR, LCMS, and melting point. Then the second step is for the evaluation of antioxidant using DPPH assays and DSC. So this is the synthetic route for my compound. BHT moiety has been incorporated into semicarbazide and thiosemicarbazide through thioether bridge to obtain multifunctional antioxidant which can offer better auto-synergistic oxidation system. These are all the synthesized compound for semicarbazide derivatives. And this is all the synthesized compound for thiosemicarbazide derivatives. So now I will show you the example of proton NMR result spectrum. I choose allyl groups from semicarbazide and thiosemicarbazide because they show a unique spectroscopic features. Interestingly, the proton NMR spectrum of these two compounds showed that the allyl group gives special peaks to the spectrum when multiples appeared, and thus give a good example for researchers to describe when not all compounds obey the N+1 rule in proton NMR. For carbon-13 NMR, peak of carbon attached to sulfur appear more downfield compared to carbon attached to oxygen. So this is the result for DPPH antioxidant activity. The radical scavenging activity is expressed by the half maximal inhibitory concentration IC50, the concentration needed to inhibit 50% of DPPH solution. Thus, the compound which has a lower IC50 value would show better antioxidant properties. The free radical scavenging properties of the synthesized semicarbazide and thiosemicarbazide were investigated by interaction between experimental compounds. The IC50 values of novel compounds obviously indicated that all synthesized multipotent antioxidants had better radical scavenging activity than BHT. In general, the reason for synthesized semicarbazide has higher antioxidant activity than BHT is due to the combination of butylated hydroxyl phenyl moiety and semicarbazide moiety in a single structure. The best thiosemicarbazide bearing naphthyl showed the significant free radical activity. This one. Based on antioxidant activity result, I choose compound naphthyl derivatives because it shows a good antioxidant compared to other compounds. Then I choose its corresponding compound, semicarbazide, to further study with TMPTO in DSC for oxidative induction time. BHT used as a standard. Here is the result for the SC or oxidation induction time of tested compound. For the both temperature, 125 degrees and 150 degrees Celsius, TMPTO blend with naphthyl thiocyanate shows the highest oxidative induction time compared to others. Based on all results, thiocyanate shows the strong alpha-synergistic effect towards free radical because it has one primary antioxidant and two secondary antioxidants compared to BHT and cyanoacrylate. So the conclusions for my presentation, for my research, is that all the synthesized compounds successfully synthesized and evaluated using DPPH assay. Evidently, based on DPPH results, thiocyanate give better impact to oxidative stability than cyanoacrylate derivatives. Compound 5F prime, which is the naphthyl thiocyanate, was the best antioxidant candidate verified by DPPH assay. In the isothermal DSC oxidation test, also naphthyl thiocyanate showed superior results as an antioxidant lubricant additive. Its oxidative induction time was 95.79 minutes at 0.25 weight% and exhibited twofold better performance compared to reference antioxidant BHT. All synthesized products are promising candidates as novel multipotent antioxidant for lubricant formulations. That's all from me. Thank you.
Hi, okay. Thank you very much, Ms. Shabira. So any questions from the floor? Okay, so this is an interesting topic. In case anyone have any questions, you may direct message to Shabila in this hoping platform as well as during the networking sessions because now is short of time. We will move to the presenter, Miss Ira. Are you ready for your presentation? Miss Ira? Okay, so you want the IT group to share your slide or you want to share the slide? Oh, sorry, you are muted. Can you unmute? Can you unmute your mic? Miss Ira, we cannot hear you. You are muted. Maybe you can refresh your browser. Can you refresh your browser because we cannot hear you? Yeah, there's some issue here. Is the IT group can help unmute Miss Ira mic? Suhaimi, Bella?
No, I cannot unmute her.
Also, she need to refresh. Is it?
I think better like that
Relax,
because before yeah. refresh.
Oh yeah, I think she refreshed now. Sorry, we need to be patient and wait for minutes lah for her to come back before we move to our invited speaker. Okay, yeah. So at the same time, if let's say the floor have any questions from Dr. Nazia and Ms. Shabila presentations, you may ask now since we have some time. Okay. Yeah, before we move to continue with the Miss Ira sessions, just wondering, Dr. Nora Zilawati is here, right? And also Prof. Asad Ali.
Yes, I'm
Can you?
here.
Okay, good. Okay, yeah, Miss Ira, welcome back. So
Okay.
yeah, the floor is for you. You want your we share the presentation slide?
Okay, let me share first.
Okay, good.
Hi. Okay, now you can see my slide.
Yes, we can see.
Okay. Um, can I start now? Because
Yeah,
I
sure.
think this is late right now.
Yeah, okay.
Okay, Assalamualaikum and very good morning to panel and moderator. Oh my God. Wait. To panel moderator and friends, I am Haziranga, a researcher from Specialty Chemical uh, under Personal Research Solubility Bangi. So today I would like to share our recent research work on the carbohydrate-based amphoteric surfactant for a sustainable and milder personal care formulation. Okay, this is my presentation outline. Here are the key message, why and objective. Let me share the screen. Okay, now you can see. Hello.
Yes, we cannot see your slide again.
Oh my God. Oh my God. This is still problem.
We
Now,
just can see the full screen, a full window, but
okay.
not the slide.
Tak boleh dia play. Okay, can your IT just play my recorded video?
Okay, sure.
Okay,
Suzaimi?
sorry, I think my laptop is problem right now.
Okay, maybe you can stop sharing so that our
Okay.
IT group can share your slide. Okay, it is ready, Miss Ira?
Yeah.
So, Miss Ira, is this a live presentation or you want to make it as a pre-record video presentation?
Oh, I thought you are playing my recording. So can we start from the first slide if you want to me to present live?
Yeah, sure. Suzaimi, please help Miss Ira.
Okay. Sorry for the any disturbance. Okay, my name is Hazira Bintinga. I am from Specialty Chemical Technology under Petroleum Research Sendia Berhad, Bangi. Why I cannot see my screen? Hello?
Okay, I think the system is not that stable. So, yeah, you may
Yeah.
continue. Yes.
Okay, today I would like to present my I would like to share our recent research work on the carbohydrate-based amphoteric surfactant for a sustainable and milder personal care formulation. Here is the presentation outline. Sorry, do you still repeat the slide, the same slide? Can I request you, can you play my recorded video?
Okay, I can because just
Okay,
now I
sorry.
cannot. Sorry, because just now I cannot because I have been muted. So I already refreshed. So now I can play for you.
Okay, so what we are going to do right now, the live presentation or you just play my recorded video?
I can play for you.
Okay, so should I start from the first page?
Uh
Okay, let me start from the first page.
you will share the video or I will share your video.
No, I already sent the pre-recorded video to the UM. Can you play?
Because Suzaimi also, I think she's muted but she don't know.
So what should I do right now?
Okay, it's okay. I will show. I will share the video.
All right, thanks.
Okay.
Assalamualaikum and very good afternoon. Before we start, let me introduce myself. I am Hazira Lindina, a researcher from Interfacial Technology under Federal Research Senior Mahat Bani. I would like to share our recent research work on the carbohydrate-based amphoteric surfactant for a sustainable and milder personal care formulation. Here is the presentation outline. Petronas now owns the technology to produce a differential carbohydrate-based amphoteric surfactant, also known as ATG sulfate with improved mildness, aimed for ultra-mild personal care formulation. We have successfully filed a patent in April 2020 to protect the ATG sulfate structure. Based on the lab's performance evaluation, we have seen that the ATG sulfate is milder and has an additional competitive advantage in the surfactant's forming behavior. This is beneficial in personal care applications. This is our ATG sulfate as attached in the photo. These slides will tell you the reason of why and objective we embark on this R&D work, which mainly focus to solve the customer's pain point. Our specialty non-ionic and amphoteric surfactant as to replace the NPE or nonyl phenol ethoxylate, a toxic surfactant that can harm the aquatic life when it degrades in the marine environment. So another R&D work will produce surfactants with enhanced mildness and important performance attributes for personal care applications. Additionally, both of these surfactants can be easily formulated into a finished product in various applications, both in upstream and downstream. Please enjoy this video.
What is soap? Have you ever thought about what soap is? The first and most importantly, there are surfactants. These are the chemicals in soap that remove germs and dirt. Surfactants attach to germs, dirt, and to water. Surfactants hold on to the germs and dirt as the water washes them away. Preservatives are added to keep microscopic bugs from growing and eating the soap ingredients. A pH adjuster raises or lowers the pH of a solution, making it either more acidic or more basic. The pH level affects how well the soap does its job. Depending on the type of soap, there are many other chemicals that can be added. These include dyes for color, thickeners to help keep the soap from running off your hands, moisturizers to soften your skin, foam enhancers to create more suds, builders to provide surfactants with extra cleaning power, and antimicrobial ingredients to kill microorganisms on your skin or body, including the ones that cause BO. Last but not least are solvents. These help to blend the ingredients and give soap the right consistency, so it's easy for you to use. Creative people like you are working to improve soap every day.
As mentioned in the video, the key component in a body wash formulation is surfactant. Surfactants are surface active agent with a head hydrophilic or water-loving and a tail hydrophobic water heating that function to remove dirt and germs from a surface. Surfactant structure can be classified into 4 groups: non-ionic, anionic, cationic, and amphoteric. It is depend on the electrostatic charge on their head, either positive or negative. Here is the background profile of amphoteric surfactant in personal care application. Amphoteric surfactants are commonly used in shampoo and soap formulation because they can reduce irritation, boost foam, and conditioning. Amphoteric surfactants include cocoamidopropylbutane (CAPB), lauryl butane, cocoamidohydroxyl sulfate (CAHF), and many others. This type of surfactant is selected due to its mild attributes and increasing product demand towards it. We can see that parents prefer products that offer safer and milder products. Secondly, is associated with the consumer's trend to ban sulfate surfactant, sodium lauryl sulfate, and ionic surfactant as main ingredients that link to irritation and toxicity. Amphoteric surfactant is one of the main ingredients used in commercial cleanser products which specifically formulated for sensitive skin for ultra-mild gentle effect. You can see them stated on the ingredient list on the product bottle. These are premium brands, unlike Dove. Now, commonly, they are using cocoamidopropylbutane. This slide shows a typical formulation for body wash. For premium brand body wash like Cetaphil, Dove, and Essential, formulators will use amphoteric surfactant as primary surfactant and an ionic surfactant as secondary surfactant. We aim to replace the amphoteric surfactants with our APG sulfate. Depending on the properties offered by the amphoteric surfactant in terms of mildness and foaming behavior, the product can be higher and be placed in premium category. Our amphoteric surfactant provides number one, ultra mild for the skin, number two, low skin irritation, number three, keep skin soft and smooth, number four, keep skin hydrated longer, number five, high foaming and longevity, number six, safe for baby and sensitive skin. This is the ultra-mild body wash formulation. We create the formulation using the common ingredient, but we just place our amphoteric surfactant, APG sulfate, and CAHS, CAPB, with the standard ingredient percent active. This is the performance evaluation framework established to assess the functionality, usability, and stability of APG sulfate. We evaluate in terms of mildness, form behavior, and stability tests. So for the mildness, we test irritation potential using zinc solubilization, and for the dryness potential, we use stearic acid solubilization. So for the foaming test, we measure the foam height and foam stability using BASH method. And the last one is stability test. We did freeze-thaw cycling stability for 5 cycles and accelerated stability testing for 3 months. Here are the results. As we can see here, our APG sulfate is performed better than commercial surfactant, CAHS and CAPB, and against the commercial surfactant. A is represent our APG sulfate and show is better in for skin damage and also for skin dryness test. Next, the foaming behavior results. Our APG sulfate in green color offers better foaming performance compared to other commercial body wash, which is beneficial in meeting consumer expectation. So our APG sulfate is higher and long-lasting foam. Then it also passed the stability test where we did freeze-thaw stability and acceleration stability. For freeze-thaw stability, we did 5 cycles and we monitored the changes. The formulations are stable as there are no separation was observed after 5 cycles. And for acceleration stability, we put in the oven at 45 Celsius temperature about 3 months, and the formulation are stable as there are no significant change after 3 months. This table shows the result achieved that our APG Sultan has been successfully formulated into an ultra-mild body wash formulation. Our product meeting all the physical and chemical properties specification, like solid content, free amine, color, based on ASTM D1500, acid value, and impurities. We also send the samples to Syrian to validate and confirm the in-house mildness test. The test conducted at Syrian is in accordance with European regulation. Skin and eyes tests use in vitro or synthetic skin and synthetic eye. This test also being used to a cosmetic company. Our APG Sultan is qualified as a non-irritant and non-mutagenic. Thus, APG Sultan emphatic surfactant is ultra-mild and gives good foaming properties. It is also beneficial in body wash formulated for the consumer with skin type needs and concerns, since it has proved by toxicological testing on APG Sultan indicates it's non-mutagenic and non-irritant to skin and eyes. We can say to it a safer surfactant to replace current amphoteric surfactant. That's all from me. Thank you for your time.
Assalamualaikum and a very good afternoon to all MIC technicians.
Okay, thank you very much, Miss Ira. So yeah, very interesting topics that now I have a much more clear understandings about the soap making process. So are you there? Any questions from the floor? Okay. Yeah, I just are wondering whether this surfactants are already commercialized or already packed in the personal care products and available in the market.
For now, not yet commercialized. We are still under R&D. Maybe we just selling the raw material, not the whole product lah. I mean,
Yeah. I mean, the Petronas already plans to have this to commercialize the surfactant additive, right?
yes, right.
Yeah. Thank you for your good words. This is very interesting.
Thank
So
you.
yeah, we will go to our next invited speakers. Thank you for the patience from Associate Professor Dr. Nora Zilawati Muhammad Sareh with the topics of synthesis of the polytriazine co-pyrrole as a conjugated microporous polymers for carbon capture applications. Right. So the floor is for you, Doctor.
Right. Thank you very much. So let me share my slide. Right. Sorry. Is it clearly seen there? The slide?
Yes, very clear.
Let me adjust it a bit.
Okay.
Okay. All right. Good. All right. Yeah, Assalamualaikum and good morning to all of you. Thank you to the chair, session chair, Dr. Lee, the session moderators, Madam Suzaimi and Ms. Shabila, also to present to the presenters and invited speaker. And same goes to the audience who joined the session. My name is Nora Zilawati Muhammad Sareh from Chemistry Department, University of Malaya, UM. So I would like to share with you today about one of my research work titled Synthesis of Polytriazine Co-Pyrrole as a Microchorus organic polymer for carbon capture application. So first of all, here is the outline. So first I'm going to give introduction and literature reviews, followed by methodology and result and discussion, and then we'll be ended by with the conclusion and references. First of all, there's a bit background and problem statement about the issue here. As you know, we are having a global warming currently, and then based on the data given by NASA, GIS 2019, the due to the carbon concentration the increase of carbon concentration that correlates with the global temperature anomalies from since 1960 until 2018. Actually, it starts when the world having the industrial revolution, when the industry uh, release emission of flue gases with the greenhouse effect, with the greenhouse gases. This has increased the CO2 concentration. There are several agreement or international treaty on climate change. I'm sorry because can you hear me because there's a background actually.
Yes, doctor, we can hear you very
Ah,
clear. No worry.
okay, because some construction my neighbors. All
Okay.
right. Okay. Right. Okay. So there is the first was related to the climate change. There was international treaty. The first was in 1997, which is we call as Kyoto Protocol, and then followed by within 7 years of 6 years ago was Paris Summit in 2015. Both under UN on the climate change, there are have this agreement that try to overcome the issue with the global warming. Even though if you can see here only 1 degree of increase, but to overcome this is quite difficult thing. So we would expect that in the near future, it's going to increase to up to 22 degrees C. Right. So the global energy consumption still more than 80%, as you can see from this figure 2. Right? And then this is due to the carbon-based fuel. So it's our the needs on the sustainable energy conversion is mandatory for us to minimize these emissions. So along with uh, a minimum emission levels, even though it's 1 degree C, it can give effect climate change very uh, difficult to restore, even more than century. So it takes time to heal. So, there's along the way we need to reduce the carbon level by certain approach. Uh, One of those is carbon dioxide removal, or in short CDR techniques, under CCS sequestration approach. Right. So this is the CDR techniques can be classified into three: physical, chemical, geological, and biological. So the one that we're going to adapt for our research is adsorption as the strategy for the carbon capture. So there are objectives that we want to achieve. The first one is to synthesize the triazine pyroconjugated Microchorus polymer at different ratio of monomers, and then followed by determination determination the surface properties of the prepared polymers using BET, for example, to determine the surface area, pore size distribution, and pore volume. Then lastly is to evaluate, for the application purpose, to evaluate the carbon dioxide uptake by all of the prepared sample. Right. This is just a brief introduction about what is porous material. Porous material can be classified under two general things. Two general things, which is first is the in terms of the pore size, pore dimension, and then followed by uh, the chemical composition. First, the size of below 2 nanometer is called as macroporous, followed by the mesoporous between 2 to, sorry, because I cannot see my mouse suddenly. Alright, followed by microporous between 2 to 50 nanometers, and then the biggest porosity we call as macroporous, more than 50 nanometers. Whereas for the chemical composition, there are three general chemical composition that involve for porous materials. There have been people been synthesized using certain material, like for example inorganic, organometallic, and organic material. So the one that we focus now is MOP, which is related to the macro porous organic polymer. Right, a bit of literature. The conjugated microchorus polymer is actually a unique compulsory conjugated polymer must be present, and also the amorphous structure. So this work has been first initiated by the Cooper and co-workers, and then followed by others. Then this can be actually tailored by different size, geometry, and functional groups that which can tune the pi conjugated porous structure. Depends on the needed desirable application. This is example of coupling reaction that we can actually find from the literature. For example, Yamamoto coupling, Suzuki coupling, and so on, including this cyclo cyclorime cyclotrimerization reaction. The one that we're going to, this our approach with this. We have this what we call as triazine, followed by incorporating the triazine with another polymer monomer, which is a pyrrole monomer. So you can see if there is a industrial release of flue gas or greenhouse gases, and then if we put kind of material like this, like for example our CMPs, and then this going to be have a physical binding with our material, and then we can release it later by apply a bit of heat, and then it can be reused. Right, for the synthesis methodology part, first thing we need to prepare BTCN, and then because we actually almost preparing from the start, so we first dissolve bromothiophene, carboxylaldehyde, CTCHO, and then dissolve in dry THF, followed by adding ammonia and iodine, and the reaction goes under inert atmosphere and added another aqueous trisulfate, aqueous sodium trisulfate. Followed after reactions done, we did a liquid extraction of this compound with chloroform, and then followed by purification using silica gel with two solvent, which is chloroform and N-hexene as a mobile phase, and then we carry out, we did rota vapor and collect the pure BTCN. And then the next thing is that to prepare the triazine. From the previous product, we took and then we dissolve it in DCM at reduced temperature at around 0 degrees, and we add trifolic acid and we react it with at room above room temperature 30 degrees for 36 hours, about 1 day and a half, and then we add later on with a sodium bicarbonate. When we got the products, we filter it and wash it with different solvents and deionized water, and then we dry it at 80 degrees C for 2 days, and then and then finally we got the triazine, which is a pale brown solid color. Pale brown solid. And then further on, we need to prepare the copolymer. This is the picture of the copolymer TPCMP1, 2 and 3. We dry the pyrrole and triazine, and by dissolving this in the chloroform, and then we add iron 3 chloride to dissolve for another, which is we dissolve it with another chloroform, and we mix this together and leave it for 24 hours for 30 degrees at 30 degrees C, and do subthermal reaction using a Teflon at 150 degrees C for 2 days, and then filter and wash it with several solvents, and then we we did a source clade extraction with methanol for 4 hours and dry it to 80 degrees C for 1 day. All this method is necessary. Actually, altogether it took about 10 days to prepare to complete the reaction. Right? So when we done this reaction, we can get it more than 98% of yield. So this is the ratio. So ratio 1:1, which is triazine and pyrrole, and ratio 2:1 for sample 2, 2 for triazine and pyrrole, and followed by more ratio of for sample 3, 1:2. Okay, for the analysis, we done the structure exsolidation. The first one is Atr Ftr, followed by solid state carbon 30 NMR, and then for the thermal stability we did TGA. For the next one, the morphology, we have done FISM, BXRD, and followed by BET. For this absorption capacity, we have done for CO2 absorption, we done GSC, which is gravimetric absorption analyzer. Most of the instrument we use it from our facilities at the chemistry department but for the BET we use it facility at the IPPP, whereas for the GSA we use facility at UTM Semarak, Jalan Semarak, Kuala Lumpur. And then move on to the result and discussion. Here is the Atr Ftr data. Okay, as you can see here, this is FTR spectra for the starting material, initial material, which is BTCHO, BTCN, and triazine. First, we can see that BTCN, each compound is already converted respectively. Each compound identified with inherent of this functional group being present, or after conversion then it become absent. So for the BTCHO is converted to BTCN, so the carbonyl group has gone and then converted to Br, so it's gone here, no more. And then when look to the triazine here, um, the spectrum, there's no trace of cyano group, which is here, okay, after conversion. And for the to find the thiophene ring, they are present between this range, about 1523 to 1519. And finally, the copolymers. Um, For the copolymers, we can show by presence of this bulky absorption peak at this range, which is around 1,500 to 1,370. Okay, so this indicating that this thiophene, uh, which is tyrosine from triazine, and also pyrrole already present in the sample. Okay. But the solid state NMR needs to show us that the polymerization or copolymerization has occurred. Initially, it was triazine, which is it had showing the carbon peak spike, very sharp peaks here, and then this showing the broad peaks, show that the copolymerization has occurred, right? And then we the first, maybe we can have a look here at this peak, the green color here at 107, and then initially it was at 883, and then it a bit shifted to 107, showing that the C, actually from CA structure, from the CA, right? And then we can see the red one for the BR carbon to BR. So there's a slightly change, but not significantly. This 107 initially was 1 to 1. This indicating carbon we attach to BR, and then followed by this 50 ppm here, considering this is related to this alkyl carbon here, which was not present in here initially at triazine, but it present here in the copolymer. Right. For the next one, this is the yield of our product. First sample and second sample, we have a good yield. Unfortunately, not a good. We haven't got a good yield for a TPC and P3. We suspect this due to the inefficient copolymerization has occurred here because the ratio of the pyrrole has been increased to 2 rather than 1. So it gives a poor yield. But for this one, the triazine, we can improve this yield by increasing the reaction time. So move on to the TGA data. Here there are TGA data of all 3 samples. So among those 3 curves, obviously we can see slightly drop down. Yeah, from the beginning below 100 degrees, slightly above 100, around 100 degrees. There's a reduction in terms of weight, percent weight for polymer 1 and polymer 3. And then, but the polymer 2 is still maintained as a very stable TGA, very stable thermal stability. Yeah. And then followed by this curve, this round here, showing that slightly reduction due to the presence of polypyrrole that have have a connection with this other substance. So maybe some decomposition here for polymer 1 and polymer 3. But polymer 2, TPCM2 still maintained. And then later on, we can see started to drop most of the sample at around 370. And then we can see finally the most stable is TPCMP2, second sample, and followed by uh, the least sample was TPCMP3. Our data is quite consistent with the previous NMR and FTR data. Thank you. So this is just a quick one. We cannot see we cannot actually observe the porosity from the FISM data, but we have proof that the micro porous structure has been found through our next data, which is but we can prove that this irregular morphology for all samples. For the PXRD, you can see here, right? Just a little bit spike, which is presenting a slightly small portion or small region of crystalline. We suspect this is from presence of polypyrrole. But generally, if we say it is amorphous, most of the sample are amorphous. Next one. So I make it quick. All right. So for this BET isotherm, the best the best data is for the uh, sample 2, followed by sample 1, and the least surface area is sample 3. So we can also observe this from the BET isotherm, give this range. So this showing that the BET surface, the best goes to the sample 2. Oh, I forgot to mention that from this data, we actually can confirm that polymer 1, TCP1, and TPCMP2 as a macroporous structure. Meanwhile, TPCMP3 is a mesoporous structure. I think this is my last data. Yeah, it's a good agreement with the previous data from BET, showing that with the this sample using the GSA adsorption studies that shows that the highest adsorption capacity goes to sample 2, TPCMP2, and then the second was sample 1, and then followed by sample 3. And then as conclusion, we managed to prepare a different ratio of typhine co-polymer trizene pyrrole CMP, and then this sample gives more than 98% yield, and we also managed to get a sensible thermostability of most of the sample, with the sample 2 give the highest stability, and only 20% for the 20% decomposition, we can reach above 375 degrees C. We can observe the irregular surface properties using FISM. Also, we can find the amorphous structure using PXRD, and BET have shown the microporous nature for the sample. And the second sample give higher surface area with the least pore diameter. Lastly, CO2 capacity give highest CO2 capacities for sample 2, and closer is that sample 1 give this almost close values to CMP2, and then this is a potential CO2 capture good CO2 capture material. And then this is the reference, and then acknowledgement to my student, the collaborators, the funding body, and also the department. Thank you.
Okay, thank you, Doctor.
Yeah.
This is a very, I think it's a crucial research project, which is about these carbon captures that is in line with the SDG goal under climate change. Yeah,
Yeah,
thank you
yeah.
for your sharing, sir. Just have one question here from me, before we go to the chat box. Okay, so is it the prepared microchorus polymer? It is just selective to the carbon dioxide absorptions, or it will be like I mean some of the others oxygens, nitrogens, or carbon monoxide gas will be absorbed in that absorbance as well.
We actually haven't tried that, but we suspect that like methane gas, it could, good binding properties with this material. We methane gas. We have a future plan for the methane gas.
I see. Yeah, yeah. Methane gas is one of the
Yes,
major gas emission as well.
yes, especially from the industry.
Yeah.
So we picked that. We suspect it's more or less about in the future we was targeting for the selectivity of the gases as well. Like for example, if we put methane gas and CO2 gas, which are more, the higher selectivity for this provided material. And
Okay.
we also using what they call it recyclability, means that after you collect and then you transfer it, you absorb, you discharge or dissolve the gas, and then you can reuse the material back.
Okay, thank you, Doctor. There is also questions from the chat box from Suzaimi. What is the advantages of these carbon dioxide absorptions compared to the absorptions? Okay.
Okay.
And then I
Uh,
continue with
okay.
the absorption capacity only show 1 millimoles per liters of adsorbents. Yeah,
Mhm.
you may answer
Okay.
both.
Okay. It's difficult to say that because whether absorption or absorption, it depends because this is preliminary work. This work was done by one of my former master by coursework actually. There are still long way to go actually. This is I would consider preliminary work from my research group. Okay, I wouldn't actually, I want to change the morphology a bit. I mean the surface of the copolymer. I want to make it more functionalized. I think it can be improved. It can improve the absorption rather than, our target is that to our target to have this reusability of the material. Most likely is the main reason of doing the research, so that we can reuse it rather than one use, okay, one time use rather than so we decided when we find that this is only physical binding, so it can be reused. So that's the ideas come of that. But in terms of the data, yeah, as I said, there are further study need to be carried out, but at least we have this insightful, a step, before the further future work, inshallah. This actually just want to share. This has been done within 6 months, maybe less, maybe less.
Yeah,
Yeah,
usually the good work will start with the preliminary
yeah,
findings.
preliminary, yeah, preliminary.
Yeah,
Mm,
good, doctors.
mm.
Dr. Zaira, do you have any questions?
Yeah, actually, what I meant was, doctor, can be checked whether it is adsorption or absorption. Hey, maybe the student, just a suggestion, very nice word. Maybe the student can study film diffusion or intraparticle diffusion Boyd plot with
Okay,
the
yeah,
time.
I
So
heard
what
that. Yeah.
happens when intraparticle diffusion is followed? There will be some criteria coming.
Yes,
Let's say interface. There is a
yes.
constant for interface C, and the Boyd plot. There will
The
be
boy plot.
another constant. So based on that value, we can tell that whether it was absorption. Absorption, it will go inside. But let's say for adsorption we can check only pseudo first order, pseudo second order, and Ilovich equation, and mth order kinetics, mth order, we call it mth order kinetics, or Bangham equation. There is another equation, Bangham equation. But if we slightly go inside that, whether it is adsorption or absorption, because to some extent there will be absorption, in that case we have to check film diffusion, intraparticle diffusion, and then we can go for Boyd plot. If the student do these things, then easily they will understand. But actually very nice work. Within 6 months, lot of work has been done. Lot of work has been done.
Yeah. Well, unfortunately, because it's only what they call it short term final, it's considered
Short term,
final
yeah.
project. So
They come also.
now it's been pending because the students already finished. So I'm I'm looking forward for another student to continue. That's why
Understood, yeah.
yes. Yeah.
Because sometimes actually Boyd plot and film diffusion, the students don't do in MPhil level also. They go to the PhD level to do that.
Yes.
Because
I suggest yeah.
Okay,
it is
thank
correct,
you.
doctor. What you have done is
Thank you,
correct,
Dr.
because
Zaira.
it's very deep, very in depth.
We are very short of time. Maybe
no
Dr. Zaira
problem.
and Dr. Nora, you can discuss in the networking platform later.
Working session,
Thanks
yeah.
again
Thank you,
for the advice or sharings from Dr. Zaira as well as Dr. Nora.
Very nice topic. Thank you, doctor.
Yes.
Thank you, Dr. Lee.
Thank you,
Okay,
Dr. Zaira.
so sorry because we are short of time. We will continue with our next invited speaker, which is Professor Dr. Asad Ali. Are you here? Yeah. Okay. Yeah, with the titles of Trends in Desalination Research for Energy Efficiency and Low Cost Water. So please welcome Dr. Professor Asad Ali.
Hello everyone, my name is Dr. Asad Ali Zaidi. I'm from National University of Sciences and Technology, Pakistan. The title of my presentation is Trends in Desalination Research for Energy Efficient and Low Cost Water Production. The work is collaborated with Dr. Yasmin Abdul Wahab from University of Malaysia, Dr. Johanna Jaffer from University Technology Malaysia, and Dr. Kingsuk Dutta from India. This is the brief introduction of desalination. Desalination is referred as a portable water recovery method by removing dissolved salts from the brackish or saline water. On the right hand side, you can see that the desalination is a nature-inspired process of salt removal. Desalination is a nature-inspired process, and in natural process, we can found in many plants and animal species, such as mangroves. Mangroves, they grow in sea, absorb seawater, and expel salt through their leaves and roots. We know seagulls; these are seabirds like seagulls, and pelicans have a gland that distills water, and we have sawgrass, extremely salt tolerant plants. This is the general layout of the desalination process. It is basically composed of three compartments. One is the intake compartment, then the processing compartment, and then the output compartment. In the intake compartment, it composed of the intake design, the pre-processing methods. Then the processing compartment is basically where the desalination process takes place, and then we have the output compartment, in which we have post-processing, which will give us the fresh water, and we have brine, which will be decomposed. Now, desalination trends. The main desalination trends are the low-cost water production. So the research on the most economical processes which are leading to the potable water. That is one research trend. The other one is the energy efficiency, which is to make the desalination a low energy consuming process by increasing process efficiency by making the process energy efficient. Energy for desalination. Despite the innovative requirements of desalination, the energy requirements are still tremendous. The world uses the equivalent of at least 2.5 million gallons of gasoline daily to desalinate water. At present, plants use 5 to 26 times more than theoretical energy required, about 0.86 kilowatt hour, to desalinate 1 meter cube of salt water, which is huge. Now the research objectives, we have three objectives. One is the process comparison. The other one is to determine the significant process, and the last one is to identify the research trends by using a bibliometric analysis approach. Process comparison, we will compare different available techniques. We will do thorough investigation of the processes. In determining the significant processes, we will analyze the technologies, available technologies based on various selected parameters, and we will determine the most significant process by using some recognized methods. We will discuss them later in our presentation. We will perform the quantitative research analysis, and we will map the research trends in the field of desalination. Comparison of different desalination technologies. The desalination technologies, they broadly been classified as thermal technologies, membrane technologies, and some other technologies. In thermal technologies, we have multi-stage flash desalination, we have multi-effect desalination, we have vapor compression. In membrane technologies, we have the very famous RO, reverse osmosis, we have electrodialysis, and we have membrane distillation technologies. And some other technologies, they involve the chemical methods, the biological methods, and some freezing distillation methods. On the other hand, oceans covers more than 70% of the Earth's surface, but unfortunately, 97% of the Earth's water have salt water. Now, let us discuss the thermal desalination process. It works on the basis of evaporation and condensation, one of the conventional methods. So, in thermal desalination process, the distillation begins with heating a liquid to its boiling point. The liquid evaporates, forming a vapor. The vapor is then cooled, usually by passing it through pipes or tubes at a lower temperature. The cooled vapor then condenses, forming a distillate. Salt remains the original flask, while pure water is collected on the other side. Then we have membrane desalination. It uses semi-permeable membrane that allows only water to pass through it. Reverse osmosis process, usually a partially permeable membrane to separate ions is used, unwanted molecules and larger particles from drinking water. The result is that the solute is retained on the pressurized side of the membrane, and the pure solvent is allowed to pass to the other side, and we have the purified water. Some other desalination methods, they involve the chemical methods. Chemicals, they adjust pH, they control scale, remove particulate, prevent biological fouling, clean, and remineralize the product. Biological methods, cyanobacterial cultures generate a large biomass in brackish and seawater, forming a low salt reservoir within the saline water. The freezing method, in this method, salt rejection is due to small dimensions of ice crystal lattice that excludes the salt ions during partial freezing instead of being incorporated in the crystal lattice of the ice. Now, the research methodology for comparing desalination technologies, we will be determine the objective goal. Then we will set up the criteria. Then we will construct the hierarchy, analytical hierarchy. We will make pairwise comparison and calculate indicator weight, consistency inspection, and if it lies between this range, then we will go for aggregate indicator weight. Otherwise, we will move back to the pairwise comparison again. Now, analytical hierarchy process is a comparative study method. The basic criteria parameters we used for these different technologies are the energy demand, global installation, CO2 release, potable water cost, potable water salinity, feed water salinity, typical plant capacity, and operating parameters, operating temperatures. And we have designated different symbols and the weightage for the basic parameters. So here we have the desalination. This is the analytical hierarchy which has been generated. So at the level 1 is our goal. The level 2 is showing different criteria from A to H, and level 3 is showing different alternatives, reverse osmosis, MSFD, and MED. So in this analytical hierarchy process, we have generated a decision matrix which is pairwise. We are comparing the one technology, one parameter with the other one, like A against A, and we are comparing all these. And the table on the right hand side is showing the category criteria and the priorities. Now, consolidated results and validation. So the consistency ratio of analytical process hierarchy is 0.0625. The fact that CR is lower than zero point 0.1 validates that the applied hierarchy process is valid. Energy demand is the highest priority number. As you can see, that it has the highest priority number, and RO is relatively best option for desalination. The fact that 155 new plants are installed globally in 2019 to 2020 verifies its importance. So this figure is showing the consolidated result of analytical hierarchy process adopted in adopted in this study. Now, the impact analysis of desalination. So we have done the bibliometric analysis, and we have developed a region-based publications on desalination. Here you can see that if we go for the country-wise, so China is leading from the front. They are producing a most number of publications, and uh, and along with the number of citations, followed by USA, South Korea, Australia, and some other countries. Now, the persistent keywords used in the desalination research. You can see different keywords, and in most of the keywords, we will find the forward osmosis, capacitive deionization, seawater desalination, membrane fouling, scaling, wastewater treatment, microbial desalination, cell water use, and energy. The leading journals of desalination. So we have categorized the journals in different categories, like A-type journals, which represents high focus on desalination as well as having the high impact factor. The B-type journals are those with high focus but low impact factor. C-type journals include those with low focus and low impact factor, and D-type journals, which have the low focus but high impact factor. So the best journals we found here are the Desalination and Journal of Membrane Science. They were spotted as type A journals, and some journals like Desalination and Water Treatment stand in the B category. Furthermore, there is no journal spotted in the C category. Now, desalination by technology worldwide. Here you can see that we have the highest percentage of reverse osmosis, and we have electrodialysis and uh, hybrid technologies on the second number, and we have multi-stage flash desalination, which has been frequently used, and some multi-effect technologies, which are contributing only to 8%. World desalination plants per geographical area. Here you can see that in Middle East we have almost 53% of the desalination plants per geographical uh, area covered. Then we have North America, Africa, Asia. The different percentages are shown over here. Distribution of renewable desalination plants worldwide. So we have the photovoltaic reverse osmosis plants at an higher percentage, followed by wind reverse osmosis and some other technologies. Now, the conclusion and the recommended future work. Comparison of various desalination technologies was done using quantitative analysis technique, analytical hierarchy process. Energy demand, potable water cost, and CO2 footprint are top three parameters that define selection of a desalination technology. Using AHP, it was determined that reverse osmosis is certainly the best choice to adopt. Quantitative investigation of literature reveals that desalination has received attention after 2000, as 94.5% of publications on desalination correspond to the period of 2000 to 2020. Out of various countries competing in research, China is observed to be on the first rank, as majority of publications correspond to a peer from China, followed by USA and South Korea. It is important to mention that if comparison is based on number of criterion, then USA leads. Topics such as graphene implications, capacitive deionization, and antifouling techniques appear to grasp attention of researchers these days. Now, the future aspects. Further reduction in energy consumption is an attractive prospect for emerging desalination technologies struggling to reach commercialization. Hybridization, which reduces energy consumption and meet water demands. Electrodialysis plus reverse osmosis to help overcome the low recovery of reverse osmosis systems. Reverse osmosis combining with membrane desalination to treat hypersaline solutions and zero liquid discharge brines. Forward osmosis, a low-cost separation process to recover the draw solution. Membrane distillation hybrids are suitable when the thermal energy can be supplied at very low cost. These are the references, and thank you very much for listening to this presentation.
Okay, thank you very much to Prof. Asad. Are you here, Prof? Yes, okay, I can see you. So yeah, thanks again for sharing your reviews on these recent trends for the desalination technologies. So any questions from the floor? Okay, maybe I can ask a much more general perspective. Maybe doctors can share your perspective and comments to us. What kind of applications that is mostly used by the Chinas or the US with this desalination technology?
Yeah, in the recent trends, if you can see, most of the publications they are related to the desalination technology, and the Chinese and the Americans, they are working very hard in this field. Mostly, they are working on the membrane technologies and the reverse osmosis is, you can see, the most prominent one technology in all of the other options. So as I said in the presentation that there are some future trends. So considering our bibliometric analysis, one who is working in this field of desalination, he can forecast the recent trends and can start working in that area.
I see. Okay, so is this technologies is applicable for the wastewater treatment as well, right?
Yes, we can segregate, like wastewater is totally different, but desalination is mostly related to the salty water. But yes, we can apply it for the wastewater treatment as well. And there are some new technologies, some new reactors which are being designed for the treatment of wastewater and desalination. Salt removal is always a major concern for an environmental engineer. So yes, this is how it is.
Okay, thank you. So any more questions from the floor? Okay, if I think if you have more questions, you can directly message lah to Prof. Asad through this Hopin platform as well as in the networking sections. So now it's come to the ends of these sections. Now we would like to announce the best presenter for these sections. Okay, so the best presenters is Miss Shabila. Okay, congratulations to Miss Shabila. So you're the best presenter. Yeah. So okay. Okay, thank you very much for all the presenters and also the invited speakers for your kind patience during this sections because they have a lot of unforeseen technical issue. So as well as I would like to thank to our evaluators as well as the moderators here. And now we are reached the end of the sessions. Thank you for your participations. Okay, so you are invited to join the next section, which is the poster sections which is start at 12:15 p.m. And if don't have any questions, we will end here. Hope to see you again. Thank you. Bye.
Thank you.
Thank you all.